Before the atom was theorized, all objects were thought to be made of earth, water, air, and fire. This remained a common belief until the year 465 BC, when Democritus, a Greek-born philosopher, hypothesized that the world and human beings were made of atomos. His philosophy states that upon our birth, we are a body shape which contains a soul that holds a shape together with warmth and energy, and in itself is made of atomos.
It took all the way until 1803 for the modern atomic theory to be created by a man named John Dalton of the UK. His theory states that all matter is made of atoms. Atoms are indivisible and indestructible. All atoms of a given element are identical in mass and properties. Compounds are formed by a combination of two or more different kinds of atoms. A chemical reaction is a rearrangement of atoms.
What they didn't know was that the atomic model was much more detailed than just a sphere. In the 1890s, J.J. Thomson, another scientist in the UK, discovered electricity was being transmitted from particles even smaller than the known atom. In 1897, he managed to show that cathode rays consist of electrons that conduct electricity. His discovery with the cathode rays led to the conclusion that the electrons were a part of the atoms. This can be observed in the creation of the plum pudding model, where there is one large sphere with a positive charge and many smaller spheres with negative charges embedded inside.
Although the plum pudding model made sense at the time of its conception, it was not entirely accurate. An experiment called the gold foil experiment was conducted in 1908 to 1910 by a physicist in Britain by the name of Ernest Rutherford, and it proved that the plum pudding model was incorrect. His experiment consisted of a gold foil, a beam of alpha particles, and numerous surfaces where which he could see the beam's endpoints. It was expected that alpha particles would travel only straight through the foil. However, it was observed that the alpha beam was flying off in numerous directions. This showed that the positive charge within the atom was actually much smaller compared to what was theorized before by J.J. Thomson.
There was still much more about the atom that hadn't yet been discovered, and as technology became more and more advanced, more detailed and accurate observations could be made with more technical experiments. One such experiment, the Millikan oil drop experiment, was performed by Robert A. Millikan and Harvey Fletcher in 1909 at the University of Chicago in Illinois. This experiment allowed for Millikan to get the precise charge of electrons within an oil drop.
But it didn't stop there. The nucleus of the atom was not just one large particle, according to the Chadwick experiment, conducted by James Chadwick of Cambridge in 1932. The nucleus was actually a bundle of both positive and neutral particles. He discovered this when particles were passed through a magnetic field like gamma radiation because they had a neutral charge. The only difference, however, was that these particles did not discharge charge electroscopes. Unlike gamma radiation, he named these newly found particles Rutherford's neutrons.
A few important details about atoms are still missing despite all of the research to this point. For atoms, size did matter. Right, ladies? Albert Einstein made a publication in 1905 explaining the movement of atoms or molecules, and he called this movement Brownian motion. This has not only explained and provided evidence for the movement of atoms, but it also allowed him to derive their exact size, and he also laid down the basis of the release of atomic energy.
Still, even more patterns were observed. In 1913, Niels Bohr of Cambridge discovered that electrons are quantized, meaning that their location was restricted to a prescribed set of values. In the present day, these sets of values are called orbitals. He also discovered that when an electron moved from a higher energy state to a lower one, photons were transmitted in the form of light.
Electrons were still shrouded with mystery until Erwin Schrödinger created the quantum mechanical model of the atom. Until that point in 1926, the position of electrons were unpredictable. This new atomic model showed probable areas where any electron could be found at any given time. Mathematical equations were used to find the probability of finding an electron in a given area.